In this video, you're going to learn how to find the values of theta in the interval. Say, for example, theta is less than or equal to 360 and greater than or equal to minus 360 for the sine function, where sine theta is equal to 0.4. So you're going to learn how to use the quadrant diagram to illustrate your values for theta, and also the graph from minus 360 to 360. And also, most importantly, you're going to learn how to read the graph itself. So for example, the phasor shift of the graph is 0, and the phasor shift of the graph has to do with how far the graph has shifted horizontally. And here, this is the original sine graph, and it has not shifted. So remember, the phasor shift has to do with the horizontal movement to the right or to the left, and here it is 0, it has not moved. The next thing you're going to learn about is the period. The period goes from one peak to the next, and the sine graph continues indefinitely. So the period for the sine graph will always be 2 pi or 360 degrees. So the period there is 2 pi or 360. And the next thing you're going to learn about is the amplitude. The height from the center line here is 1. So the amplitude is 1. And okay, and also the amplitude here for this would be 1 as well. 1 unit. And then the next thing we need to look at is the vertical shift. Here the sine graph is in its original position. It has not shifted vertically. But you need to know that this graph can also be shifted vertically, whether downwards, which is negative, and upwards, which is positive. Now let us quickly look at sine theta equals 0.4. So this is a sine graph, y equals sine theta. 0.4 would be somewhere here. So we draw a horizontal line through 0.4, and wherever it cuts the graph, we read downward for our value of theta. Okay, so here this would be a possible value, and that's a possible value, and here that's a possible value, and here that would be a possible value. So there are 4 possible values in this range. But it's very difficult because in the exam you don't have a graph to scale, and you're not required, you were not told to draw the graph to scale. So this is just a sketch. So the quadrant diagram will help you to work out the possible values. So here in the first quadrant, all the ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. And this is what we call the cast diagram, C-A-S-T. Now, since sine theta is equal to 0.4, which is positive, it means that our possible solution for theta would be in this quadrant and this quadrant. Now what we do, we draw an acute angle from the origin here in the first quadrant, and also we do the same in the second quadrant, and they have to be the same size. So here is another acute angle, and we mark them. So this angle and this one are equal. Now let us now quickly illustrate the possible solution that we could have between the range that is given here. So let us look at the positive values first. So here 0 or 360 degrees would be here. That would be 90 degrees. That would be 180 degrees. And that would be 270. Now it's important to note that going in the anti-clockwise direction, we take that as positive. And going in the clockwise direction, we take this as negative. Okay? So now let us look at the positive values for which we would have for theta. So our first positive value would be this angle. Our next positive value would be from the 0 to this angle here. Let's look at the negative values for theta. In the negative direction, we need to move from 0 to this angle here. Okay, so that would be a negative answer for theta. And the next negative value for theta then would be from 0 to this angle right around here. So let us mark it right around here to this angle. So there are 4 possible solutions, just like what the graph is showing here. So the first angle would be an acute angle. The next angle here would be an obtuse angle. And the next one would be a reflex angle. So theta then would equal to sine inverse 0.4. And when we input that in our scientific calculator, we get 23.6 degrees to 1 decimal place. So it means that our first angle here is 23.6 degrees. That's a possible solution. So let's write this as 23.6 degrees. Now remember, this angle is 23.6 degrees. So if we want to find this angle, we know that all of this angle here come around here is 180 degrees. So all we need to do to get this angle is to subtract it from 180. So upon subtracting 23.6 from 180, we get 156.4 degrees. 156.4 degrees. So that's our next angle. So these are the positive values. So let's just mark this with our highlighter. So that's the positive value there that we have, and this one. Now let us work out the negative values for which we could get for theta. So here we're going in a negative direction, so that would be negative 180 plus this angle, which is a negative 23.6. So that gives minus 203.6 degrees. And then we want this angle. So here we would, from here to here would be minus 180 degrees, added to another minus 154.6 degrees, and that gives us minus 336.4 degrees. So let us highlight all the possible angles then. So we have minus 203.6 and minus 336.4 degrees. So it means that we can write the values for theta in ascending order, which is minus 336.4 degrees to 1 decimal place, then minus 203.6 degrees to 1 decimal place, and then 23.6 degrees and 156.4 degrees to 1 decimal place. So these are the solution for the values of theta in the range given. Thank you very much.